Hi, welcome back to another video. This week we're actually taking a look at ScrollView again. I got a suggestion from one of the viewer that he wants his ScrollView to stop immediately when the user stop dragging. As you know, with the default ScrollView, when you do a scroll, the scrolls keep going, right? And then it will come to a stop, basically decelerate until the stop point. But we're gonna try to take it out completely today. As is shown in front of me is kind of the final product. So if I scroll back to 0, it's gonna bounce. But if I scroll and as I'm scrolling, it doesn't keep going. It just stopped wherever I left it off at, right? If you click on this video and you not no interest into making this force stop effect, I still recommend you stick around because basically you're gonna write a UI kit wrapper for ScrollView, but we're gonna convert able to use that in SwiftUI. So if you really don't want to use the default ScrollView, you can also using this wrapper, right? With UI kit, you have a lot more customization to your ScrollView, which I think is a way better approach than using a default one. So let's get started. In front of me is an empty project. In order for us to use UIScrollView and SwiftUI, we must wrap it in UIView assemblable. So let's get started with making our struct call. Let's say call for stop ScrollView. All right. Naming always hard in programming. UIView representable. First, we gonna wait for the error come up, so it's help us like autofill. We're gonna be using UIScrollView here. Give it another second, it will come up this up. All right, I won't be touching this, so let's show it. We're gonna create our view and then call UIScrollView and then return view. We're gonna start with configure our ScrollView. So let's call view.delegate equal to context.coordinator, and we say view.eScroll enable equal to true. Right, then this is gonna start throwing an error because we don't have any coordinator. So we're gonna start with that. So let's also make our class coordinator, and then ns object, and then UI ScrollView delegate. Right, and then we need to fill out what make coordinator, I believe. Yes, coordinator. So the reason why we want to use UIScrollView delegate is that I want to able to use this function. Since the force stop have to do something with user either stop dragging or the deceleration come to stop. Well, if you go to the document and you go to the response calling and dragging function, if I go down the list, the only possible solution is queue and dragging. So maybe when user stop dragging, I just stop the animation. I tried there, it didn't work at all. So and then we keep going down, scroll to top, no, and these two seem to be a feasible solution. So I prefer use will beginning decelerating to prepare for the stop, and that's why we're gonna do it here. So ScrollView will begin decelerating, right? So that will silent our no, not my bad. That was gonna be a setup skeleton, right? So we're gonna come back to it later. Here, when you go back to our regular view, when you call ScrollView, I'm not interested in any of this. I want you to have this thing, right? So I can embed it more view within it. So to do that, we're gonna put here for the content, we're gonna conform it to view here, and we're gonna make our initializer. So let's content equal to content init, and I believe view builder come first. View builder content let's see, this is gonna return a content, and then we say that cell.content should equal to lowercase constant with, let's delete this so it doesn't throw an error. So now we will be taking in a view here, and in order for us to use a view in SwiftUI in UIKit, we must embed it into a UI hosting controller. So let's say add child here. Okay, we need to add the content view into the scroll view, right? So we're gonna say that let child equal to UI hosting controller. Let's say a root view should be content with a low. I'm just gonna type it out. Alright, so now we're gonna say view dot add subview. So our scroll view add the subview will be child dot view. Right, and one more thing we need to configure is we need to configure the size. So in UIKit, in order for you to make ScrollView work, you need to set the content size so ScrollView know how much they allow you to scroll. So, but however, getting the size of a view in SwiftUI is a very difficult process. You probably have to do some sort of like geometry trick just to get it, but that's not necessary in UIKit. You can use a function called size.fit. So let me demonstrate a new size. Go to child dot view, and I'm gonna call size.fit, and that requires to pass CG size. CG size is require a width and the height. And here I'm just gonna say UI screen dot main dot bound width. Actually, I'm gonna make a struct for this. All right, let's call struct screen static let width equal to UI screen dot main dot bounds dot width, and we're gonna do static let height equal to UI screen. Same thing. Main dot bounds dot height. So here I can shorten the call by this screen dot width. This is actually my favorite struct I use in a lot of demonstration and project. So not supposed to be a generic type. I don't think you need a static here. Okay, you don't need a static. Here is expect us. Yes, we actually delete the thing. And height, we're gonna call greatness finite magnitude, right? Let's say child view size.fit. Screen cannot be used on type for soft screen. Did not mean to use value of this type instead. You know what? This makes things complicated. We're just gonna move this out. So you also have the later use for it as well. That shouldn't silence the warning. Cannot be used on screen. Do you make sure? Why does it say that? Is this static? Let this off. Okay, so the static was right. It was tripping out for me for some reason. And now we got the new size. We're gonna set our child dot view dot frame equal to CG rect. The frame is typically CG rect. Gonna be 0 here, 0 here. Width gonna be new size dot width, and new size dot height. Right, and then we're gonna also we're gonna set our content size for our scroll view. Get a new size. That should typically sound in the warning. Yes. Now we have everything set up. We're gonna go down here. We're gonna do something with this scroll view. So here I want to say let y offset scroll view dot content offset dot y, and then we say here if y offset plot screen. There's no autocomplete. Plot screen, that should be less than or equal to ScrollView dot content side dot height. Right, and we say and y offset bigger than I wouldn't say -20. I usually give a -20. Alright, now we have that. We go now here is the line that will help you stop the scrolling. So we say set content offset. So we can do ScrollView dot content offset. Anime can be false. Alright, let me explain this line real quick. The first part is this is not the first part, but the second part of this. The reason why I say content offset is equal to -20 is that if we look at the simulator, when I scroll the y offset, if the y offset past 0, or I set it to -20, basically when you go here, this probably is where -20 is right here, then I'm not gonna set the offset. I'm gonna let the system taking care of bouncing back to 0. Same thing for the bottom right here. Is it past the content size? I'm gonna let the system taking care of bouncing back. Let's see. If you don't believe it, you can just comment out, take this out, and do this. You run it. Give it a second to build. I forgot to set up the main view, so give me a second. I'll set up. Alright, so I'm back. Let's see. Now we have this. Now if I don't have the checking, let's say if I scroll past 0, I can just continuously keep scrolling, right? Eventually this will get to the point where you make very minimal scroll like this. As you see, the farther you scroll, the slower it get. That's not what we want, right? And then eventually there's a point, I don't think, where you can scroll anymore, or you can scroll but a very small amount that you can't even see it. So that's why we have this line to check for the top and the bottom constraint of our view. So let's uncomment this. And paste that in. Now let's run this again. So now here, if you have to pass the bottom, it will stop. If you pass the top, it will bounce back to 0. The ScrollView, the force stop is not that prominent when you have very little amount of item. For like if you have like 60 item right here, you can see there's a stop, right? Like if I scroll, it's still running fast. So let's increase this to, let's say 100. Let's say 150. We're gonna almost triple the amount. See, even if I scroll fast, it stopped, right? It stops very suddenly. Oh. So yeah, this doesn't work well if you have very small amount of view and the user won't notice it, but you have like a large number of views stacking each other like this, you will see it. That's pretty much it. If you don't want to have the force stop effect, then you can just comment this out or delete this, and cater the code to whatever your project need. This I think I really like this because I have a lot more control over what the ScrollView does rather than using the default ScrollView. So if this video helped you out, or if you stay to the entire video, thank you so much. I hope this really helped you out, or open up something in your projects. Please give a like and subscribe, and I hope to see you guys next time. Bye.